Now.
Yes.
Action.
Okay, so we're continuing this page that we were on Thursday last week. We've gotten to, we finished 18, which was pi 8. On number 19, it says how many times, this should be would instead of with. How many times would the length of the radius fit around the circumference? And so what I want you to think about on this problem is circumference equal 2 pi r. And so your answer is going to be c over 2 pi. It's just a formula answer. C divided by 2 pi. Since it's c equal 2 pi r, we're solving for r, so it's c divided by 2 pi. Number 20, an angle which measures 1 radian is about how many degrees? So remember on this, we have pi here, which you can think is 180 degrees, but you can also think of it as 3.14 something. And this one is 90 degrees, which is pi halves, which is 1.57. So because of that, 1 radian would be between 0 and 90, or 0 and 1.57. So I'm just going to put it right here. That's the visual part. And so how we do it is do your conversion 1 radians and 180 over pi. So you basically just do 180 over pi on your calculator and you get 57.3. That's right here. 180 divided by pi is 57.295, so forth. Make sure you're in degree mode if you do that. So that'd be my note here. Make sure you're in degree mode. So 57.3. Any questions? Okay. These are similar to things we've done, and I don't have time to go over the entire packet today, so these are ones that you're going to do. Remember to cross out the bottom part of the sheet. Okay, so now for this part, use your unit circle to answer the following questions. In what quadrants is sine positive? So remember, this is like what I had you draw on one of your homework assignments. This is quadrant 1, this is 2, this is 3, this is 4. And cosine relates to x, and so cosine would be positive there and there. And secant is related to that. It's 1 over cosine. So remember, if it's to the right, then cosine is positive. If it's to the left, cosine is negative. So remember, it goes x comma y with cosine comma sine. Sine would be positive up. So sine is positive here as well as here. Sine relates to y, and so it's positive up. And then the partner of that would be cosecant. Tangent would be where it's positive divide by positive, or negative divide by negative, which is in quadrant 3 and 1. And the partner of tangent is cotangent. So you have cotangent positive here and here. So then I'm just going to write Where it's not listed is negative. Where it's not listed is negative. So, for example, if sine is positive here and here, then sine is negative here and here. Okay, so for our question, in what quadrants is sine positive? It's 1 and 2. Using Roman numerals. And sine is negative in 3 and 4. Cosine is positive to the right, so it's 1 and 4. And negative in 2 and 3. And tangent is positive in 1 and 3. And negative in 2 and 4. It doesn't matter if you put the little lines above it, like there's where I have to, or if you just do it like with tick marks. It doesn't matter. Okay, so then it says find each trig ratio for the angle measure. So to do this, you say 120 degrees, and you go to your unit circle, write down the ordered pair. So for 120, it's negative a half with square root of 3 over 2. So for your sine, remember that's y and then x and then y over x. So for your sine, it's square root of 3 over 2 because it's the y answer. And the cosine would be the x answer, so negative a half. Your tangent is y over x, so your 2's cancel, and you've got square root of 3 over negative 1, so that's just negative square root of 3. Any questions? Yeah, so I wrote down my ordered pair, and then sine is y, cosine is x, tangent is y over x. Okay, so 7 pi over 4, look for that on your unit circle, and you'd find square root of 2 over 2, comma, negative square root of 2 over 2, because that one relates to 315 degrees. I put the degrees just for reference, but that's not really an answer. So it's up to you as to whether you want to or not. Good question. And then sine would be negative square root over 2. Cosine would be positive. Tangent would be when it's the top one divided by this one. So your 2's cancel, and then you're left with just the same thing except for one of them's negative. So it's negative 1. They're identical except for the negative sign, so it's negative 1. Okay, and then this one says theta is negative 120. So what we want to do is add 360 to that to get the coterminal is 240. And so that ordered pair is negative a half, comma, negative square root of 3 over 2. And once you have your ordered pair, it's easy. So this is negative square root of 3 over 2. This is negative a half. Remember that the y goes with sine, the x goes with cosine. Then for the tangent, since you have a negative, divide by negative, it's positive. And so this would have the 2's cancel, so you're left with square root of 3. Since it's basically square root of 3 over 1. Okay, on this one, you have 7 pi thirds. So one way to approach this is to do 7 thirds minus 2, because since 6 thirds is 2, it's looping around more than once, and it's 1/3. So that means pi thirds. So that's 1/2 comma square root of 3 over 2. The other way to do that would be, say, 7 times 180 over 3. So that's 7 times 60, which is 420.
420?
Yeah. And then since that's bigger than 360, you subtract and you get 60. 60 degrees is equivalent to pi thirds. And so then that's your ordered pair. So either approach, whether you want to just subtract 2 because 7 pi thirds is too big. See, it doesn't show up on here. 5 pi thirds is there. 6 pi thirds would be where 2 pi is. And then 7 pi thirds would be here, looping around like that. So once you have your ordered pair, then sine would be square root of 3 over 2. Cosine is 1/2, and tangent, your 2's cancel and you just get square root of 3. Okay. And this one is very much like the other one we did today. 1 radian is how many degrees? Yeah, we did 180 over pi, and that's 57.3. 57.3. Good. Okay, so then this next one says, find the value of theta without a calculator, use your unit circle. There is more than one answer. So this is very important, because if you did use your calculator, you'd say theta, theta equal sine -1 of -1/2, and you'd only get one answer. Okay, so I'm here at a blank screen. I press the trig button, sine -1. I'm showing you why this is wrong. Sine -1 of -1/2, that gives you -30 when you're in degree mode. So we're supposed to use the unit circle instead, because that just tells you one answer and it doesn't even tell you it in the right form. So what you do instead, look where y equal -1/2. Look where y equal -1/2. So we're looking for 11 pi over 6, which is 330 degrees, and 7 pi over 6, which is 210. So 210 and 330 are your answers. So if you use your calculator, you only see one answer, not two. And now -30 would have been coterminal to this, but we'd need it to be 330 with 210. If you want to think of it as 180 plus 30 is 210, and 360 minus 30 is 330. Because of where we are here and here. So we're going a little further than 180, and we're going a little short of 360. Okay. Then this is cosine negative square root of 2 over 2. And so this is where x is negative. So that's going to be on the left side with a reference of 45. So this would be 135 and 225. $135 and $225. So basically what you're doing is you're looking at where x is negative square root of 2 over 2, which is at 135, and the other place is at 225. This next one is where it's positive square root of 2 over 2 for y, because sine is y, cosine's x. So that'd be this one, which is 45, and this one, which is 135. So 45 and 135. Any questions? Okay, then you have tangent, which is y over x. And so it doesn't show up exactly on your unit circle. You've got to look at different combinations with the y value having square root of 3 or square root of 3 over 2, like this one, for example. Square root of 3 over 2 divide by a half, your 2's cancel, and so 60 degrees is an answer. And the other one where it's negative square root of 3 over 2 divided by negative a half, that would be square root of 3 also, and so that's 240. Again, if you want to write down the ordered pair, you can, but that's optional. But that's basically how I figured it out. It's y over x, and so we had to use the square root of 3 over 2 as y, or negative square root of 3 over 2 over negative a half. All right. Okay, the next one you do something very similar, but instead of degrees, this time we do it with radians. Yes.
Test me over this stuff?
This is similar to what's on 6.1 and 6.2, so yes. Yeah, and you can use the this for that.
Okay.
Yeah, you can use it. I have the reviews printed. Y'all could pick one up early at the end of class. The test is Thursday. Not yet. Yeah. Anytime I reprint it, it gives me different numbers. So, yeah, don't have that yet. Find the value in radians without a unit, without a calculator. This one is where y is negative square root of 2 over 2. So, for this one, it's downstairs, so to speak, and so this would be 7 pi fourths and 5 pi fourths. Seven pi fourths and 5 pi fourths. Okay, then this one is the cosine is square root of 3 over 2, so that's x. Look on your unit circle where x is square root of 3 over 2. It's right there, so that's pi 6. And it's also right there, which is 11 pi 6. Pi 6, 11 pi 6. Okay, this one, cosine is negative a half, so that's going to be x. Just Just remember cosine is x. Bless you.
Thank you.
And so for negative a half, it's here, which is at 2 pi thirds, and here, which is 4 pi thirds. 2 pi thirds, 4 pi thirds. You kind of use your unit circle as a reference sheet. Look where the x answer is negative a half. Okay, then 16, tangent theta is equal to negative 1. So that's where they're identical, except either one is, you either have one positive or one, well, you're going to have one positive and one negative. So for example, negative square root of 2 over 2 divided by square root of 2 over 2 is negative 1. And if you have the opposite, that's also negative 1. So that happens at 3 pi fourths and 7 pi fourths. 3 pi fourths and 7 pi fourths. Remember that it's y divided by x. So basically where they're identical, but one of them's negative. Okay. Then the next one, it says name the angle. It should have said name an angle in quadrant 1 in radians. So look at quadrant 1. And so sample answers would be pi 6, pi fourths, or pi thirds. So choose pi 6, pi fourths, or pi thirds. All are correct. Just wants you to get used to naming an angle in radians. The next one says name an angle in quadrant 3 in degrees. So on this one, choose, let's see, quadrant 3, that'd be 210 degrees, 225 degrees, or 240 degrees. Again, all are correct. So just make sure you know where the quadrants are. Any questions? Okay. Now this page, remember we crossed out because this has more to do with graphs, which we haven't done yet. And so now we're on this side. These are similar to what we've been doing, so you can do that part. Yeah, so 230 degrees. It's like what we did here, actually identical, 230. But then the next one is 7 pi 6. So the whole worksheet is not identical. What we basically do is we put 0 here, 180 here, 270 would be there, so we loop around a little bit. And that's it. So that's number 1. Okay. Okay, so now these, you want to know the coterminal and the reference for each. So the first thing is for the coterminal, we're going to use these two blanks. And so we're going to do plus and minus 360.
How do you know that?
Coterminal, Well, if it's in degrees, it's plus and minus 360. If it's in terms of pi, it's going to be plus and minus 2 pi. How you know it? It's like what we did right here. Find a positive and a negative coterminal, plus and minus 360, or plus and minus 2 pi. Yeah. So like those, or like these, find a positive and a negative. It says that. Okay, so good question. So 225 plus 360, that's 585. And 225 minus 360, that's negative 135. Put a comma between. Now what the reference is, if it's in degrees like 225, then just find it here. And so in radians it had a 4, so that means it's based on the 45. If it were a 6, it'd be based on 30. If it were a 3, it'd be based on 60. You know that from here. If it's 4, it's 45. So ref equal 45 degrees. So those are your 3 answers.
Wait, and how do you know that it's 45 degrees?
Because I find where 225 is, and it has 5 pi over 4. So then you can look at pi over 4, which is 45.
Got it.
Your reference is always between 0 and 90. Yeah. Good. And for this example on 11, 3 pi over 4, this one, you know, if it's already in terms of pi, your reference is going to be that part, which is pi fourths. Reference equal pi fourths. And on this one, we do 3 over 4 plus 2 and 3 over 4 minus 2. 3 divided by 4 plus 2, that's 11 fourths. So then you put 11 pi fourths. And 3 over 4 minus 2, negative 5 fourths. So negative 5 pi over 4. So those are your 3 answers for those. Y'all could do the rest of these. I will help you as far as the reference. The reference on this one is a positive 30. The reference on this is pi thirds, and the reference on this is just 53. It's got to be a number between 0 and 90 if it's in degrees. So y'all do the, the other 2 blanks from adding and subtracting 360, or adding and subtracting 2 pi. Okay, and again, you should be able to do these, convert degrees to radians, or like look at your unit circle. All those are real simple. Like 45 degrees, just find it. It's pi fourths. So look on the unit circle, or use formula like times pi over 180 or times 180 over pi. Okay, then we'll do 25 together. What is a unit circle? Draw a picture and draw a sentence to describe it. So first, let's draw a picture. Draw a picture. And let's label these 1, 0, 0, 1, -1, 0, and 0, -1. It also says write a sentence to describe it, and what is a unit circle. So it's a circle with radius 1, and there are exact answers. For multiples of 30 degrees, 45 degrees, 60 degrees, even 90 degrees. Okay, so a unit circle is a circle with radius 1, like what we drew. There are exact answers for multiples of 30 degrees, 45, 60, and 90. For sine and cosine and that. Any questions? Okay. This page is supposed to be crossed out. Completely. This part's a duplicate, and it's okay. This is similar to the one we just did. It says define a unit circle, but then it says using words, how do you construct a unit circle with the help of two specific triangles. So as an example, use a right triangle in all 4 quadrants for 30 degrees, 60 degrees, and 90 degrees with hypotenuse 1. With hypotenuse equal to 1. Hypotenuse, or you could have put radius. Hypotenuse or radius 1. Okay, so for example, there's a right angle. I want these two identical. So that means they're 45, 45, 90. And so this particular point would be for 45 degrees, it's positive square root of 2 over 2, positive square root of 2 over 2. So that's what that dot on the unit circle would be. For 45 degrees, it's right square root of 2 over 2 and up square root of 2 over 2. And you could do that for 30, 60, 90. For 30, 60, 90 also. And remember, what we're labeling as the hypotenuse is 1. Okay, any questions about that? Use a right triangle in all 4 quadrants for 30, 60, and 90 with hypotenuse or radius equal to 1, and then I drew a picture. Okay, draw the angle, convert to degrees or radians, and label the reference angle. Okay, so this one's 5 pi over 4. So for that, it says radians degree conversion. So let's look at where 5 pi over 4 is, which is here, and it's 225 degrees from the unit circle. Since it's in radians, we want to put it in degrees. and we just found it on the unit circle. Then it also says to draw it, and so I would think 0's here, pi is here. Since 4 is my denominator, I can think of that as 4 pi over 4. Pi is the same thing as 4 pi over 4, so 5 pi over 4 would be like in the middle here. So that's your drawing. And it also wants the reference angle, and so that's going to be the part to the x-axis, which is pi force in this case. Remember, the reference angle is to the x-axis, not the y-axis. Okay, then 240 degrees, find it on the unit circle, and you get 4 pi thirds. And if this is 180 and this is 270, it just loops around like this. And your reference is this part. So to get that, we do 240 minus 180. So your reference is 60 degrees. It's not this part that's 30. It's that part that's 60. Okay, then 300 degrees. Well, this is where 270 is. This is where 360 is. So 300 would be around here, going around like that. If you look at your unit circle, the conversion on that would be 5 pi thirds. And your reference is 360 minus 300, which is 60 degrees. And then for 5 pi 6, this reference would be pi 6. And pi is here. So pi is equivalent to 6 pi 6, so 5 pi 6 would be around here. Like that. So here's your... Oh, you know what? I put this as my reference. The reference is pi 6. The equivalent degrees to that is 150 degrees. 150 degrees. Any questions?
Dang it, man.
Okay. And then for an example problem here, using the unit circle in a sketch, find the exact value of the following. So for 240 degrees, we're over here. Your ordered pair is -1/2, negative square root of 3 over 2. What that means is you're going left 1/2, you're going down square root of 3 over 2, and your hypotenuse is 1. And so then you want the x answer. So that's -1/2. So make sure you do the drawing as well as get your point. So that's an example, and you do these. You do these three. And then for an example on this, sine is y. Remember, that's opposite over hypotenuse. The positive quadrants were 1 and 2. The negative quadrants were 3 and 4. All these at the bottom, that's fine. So cosine would have been 1 and 4. So that means 2 and 3. Tangent would have been 1 and 3. So 2 and 4. Yeah. And there's a smaller copy of this. Okay, so y'all do the ones that we didn't do, and it's due tomorrow.